Hi all. Today I am going to present second session regarding CO4. Okay, the topic is applications of cryptographic hash function in cryptanalysis and cyber defense subject. Okay. The aim of this session is to make the student more awareness on basic concepts of hash function and applications of hash functions. Coming to the instructional objectives, the objective of this session is to introduce the basic concept of hash function, and also it provides the necessary theoretical background and demonstrate the applications of hash function. Coming to the learning outcomes, at the end of this second session you should be able to define a hash function and also understanding the explanation of list of applications of hash functions. So here what are the applications of here this session describes the concepts of hash function and applications of hash functions. See, in this regard in order to understand the source has to send a message to destination. So what exactly the source need to send? Here the source need to send calculated hash value of messages, okay, and appends it to the message. So because the user wants to send a message to destination, the sender needs to calculate the hash value of the input message, okay, and also along with the message it appends to the message. So here the message the given message together with hash value is encrypted using the secret key and any symmetric encryption algorithm, and also is sent to the destination also. Okay, every message need to send a destination has to make sure that the message is correctly received or not, okay, and also see the destination person also verify that the message is clearly received and that message is to be no one modified, okay. So in order to message the unique message which is to be received, the same key, secret key is to be used for decrypt the message along with the key hash value, and also compute the hash value to provide the relevant message which is to be compared with the hash value which is to be calculated at the destination, okay. Whatever the calculated value in that source, the same value which is to be calculated at the destination. Is it clear? So in order to implement the hash function, please make sure that the comparison of hash values are very important. Comparing of hash values which are done at sender side as well as done at receiver side, okay. If the hash value of sent by the source is and hash value computed by the destination for the received message are same, it means that the message is received at a destination without any modification, so that the integrity of the message has been preserved, the integration of the message has been preserved. This is the description. Coming to the applications of hash function, this is the usage of hash function in message authentication. Here symmetric encryption been used. Here the source person M send a message to destination. First of all, the sender of the message calculate the hash value through this hash function and appending this message with some padding characters and then apply the encryption process on the hashed message with that key. This is called key. This key, whatever the key which is used for calculation, the same key is used at the destination, okay. So once the encryption of the hash function with the key, that is we call a E of k comma hashed input of message M pairing with the hashed message, that has to be sent through over internet. Then this destination receives the message and decrypt the message using decrypt algorithm, decryption algorithm using the shared key which is to be available at destination, and then recalculate the message with hash value of the message, and comparing the message which was done at sender, and that will be compared with the receiver, and then the once message is received is equal to the calculated message is equal, then the message has been received properly. If the message is tampered, the comparison of the two values is not matched, so that the receiver could not receive the message because of the message is tampered. Okay, is it clear? So then we see the more we see the more clarity on this message authentication algorithms in order to describe the hash function. Okay. So digital signature. What is the digital signature? Digital signature means encrypting the hash value of or a MAC value of message with private key. With the private key. So in order to the sender transmits a message to the destination, the destination makes sure that whether the message is properly done by created by the sender or not. C, in order to destination authenticates the message from the sender, the destination will recheck the message through this private key. Okay. So here the source calculates the hash value of the message and encrypt it with the private key of the source PR using a pseudo-random algorithm. Then that will be available at the sender, and will be message will be appended with the encrypted hash value and sends the destination. In this regard, digital signatures are implemented. So in order to design the digital signature, the source, that means the source A wants to send a message to destination B. The message has been message has been provided with H to produce the message as a function, and then apply the encryption on the given message PR pure random algorithm with private key, and produce the pattern message that will be sent to the receiver. That means destination. Destination recalculate the message with their public key and then decrypt the message and produce the relevant output message. So it will be comparing with this message with the source hash value, so that when it both are matched, the message is been not matched, the message has not been changed. So coming to these are the various things discussed. So and other applications of hash function is it has to be created one way password value. Okay. So this is the first application where the real time users can use it. Okay. So in Gmail or other social media where the hash function being used, because to create a one way password file. Okay. And second one is it is used in introducing detection and marriage detection methodologies. Okay. And also it is used to construct a pseudo random function PRF, or also a pseudo random number. Okay. It should be emphasized with this hash function through these digital signatures. Okay. So it is it also must undergo the continuous scrutiny and evaluation in order to identify the potential vulnerabilities, and also ongoing research and development efforts will be put into force. Okay. So these are self-assessment questions. First question, identify hash function application among the following. Here data encryption, data compression, data deduplication. Here the second data compression is one of the hash function act as an application. Okay. Then the second question is identify the primary use of hash function in preserving the integrity of data. Okay. And also see the answers, ensuring the data confidentiality, detecting the unauthorized access, okay, verifying the data integrity, and also see the encryption of data during transfer. So the primary use of hash function in preserving the integrity of data is ensuring that the verifying the data integrity. The C is the correct answer. Coming to the third question, when storing password, hash functions are frequently used to generate random passwords. Okay, generate the random files. And also the fourth one, create hash values of passwords for verification will also be considered. And fourth question is, hash functions are frequently used in blockchain technology. Okay, so because storing sensitive data securely, so hash functions are frequently used in blockchain technology for storing the sensitive data securely. Okay. And the fifth question is, which of the following instances of digital signatures uses a hash function? So here uses of hash function for the sake of creating digital certificates. Okay. And also the hash functions are used for content addressing in distributed file system. So in order to distribute file system addressing, so we had to see the compress the files to reduce the storage space, and also see the integrity. And seventh and eighth questions, applications for hash function data deduplication includes storing data in distributed storage system, as well as the compressing the data to reduce the storage space. Okay. Eighth question, what is a hash function which is being used to calculate the checksums which are frequently employed in network protocols. So here the encrypt the sensitive information. And ninth question is, hash functions are important in digital forensics because of they help detecting file tampering and manipulation. Okay. Coming to the hash function, which are used for content based routing in distributed systems to encrypt the sensitive data during transmission, as well as the optimize the network bandwidth. Okay. So these are the 10 questions which are coming in the examination. So list of the hash functions, demonstrate the messenger authentication with need diagrams, illustrate the digital signatures with need diagrams, list other applications of hash function and all. So these are the textbooks which are discussed. Thank you.